Afternoon, folks. My name is Tejas, and along with me today we have
Pen Fan.
And then Dongju.
Okay, and today we'll be talking about logistic regression. But before we get into the presentation, I'll give you an overview of what we're going to be talking about today. Firstly, we'll be talking about the background, some of the applications of logistic regression, and we'll be finishing it off with some of the limitations around logistic regression. So how did this all come about? Well, two folks, Kutelet and Verhulst, in the 1830s were looking at growth rates. And to quantify this, they came across a model. And they were struggling behind the mathematics behind this, and Kutelet asked Verhulst to help him out with this. In terms of the data science and how this fits into what we're doing today in class, it does not fit in until 1940s, when a person called Joseph Bergston came along and tried putting this into an industry where we could use it now. So what is the logistic regression? So it's a statistical method used to model binary outcomes, ones or two, using a predictive variable. It uses a sigma-squared function, as you can see on the screen. And we're able to do this with one predictive variables, or we'll also be able to do this with multiple predictive variables, as you will find out soon.
Alright, in the following situations, logistic regression performs better than other methods. The first one is that the dependent variable is the categorical variable of two classifications or the incidence of an event, and is a numerical variable. The second one is both the ratio and the dependent variable are subject to the binomial distributions. The third one is that the independent variables and logistic probability are linear relationships. The first one is that each observation object is independent of each others. Okay, I think it is a significant step that Euler and Wilson further refined their model. With Wilson is the first people to apply logistic to biases. Since then, the equation has been widely used in the field of biomedical. Okay, the dependent variable of logistic regression is usually two categories. Taking the gastric cancer disease analysis as an example, two groups of people are selected. One group is a gastric cancer group, and the other one is non-gastric cancer group. Okay, the two groups must be different signs and lifestyles. Therefore, the dependent variable is whether it is a gastric cancer. If the value is yes or no, the independent variable can be include many factors, right? Such as age, gender, eating habits, and so on. According to this, finally, we can roughly understand which factors are the risk factors of the gastric cancer. At the same time, according to the weight value, the possibility of a person suffering from a cancer can be predicted according to the risk factor.
Okay, therefore we can say logistic regression can work on the data set which has a linear boundary to separate the data into two parts, neither 1 or 0, neither yes or no. However, there are still some limitations when to apply it. The first limitation is the logistic regressions needs all relevant independent variables, or the model will not create a accurate result. The second one is the logistic regression requires each data in the data set is independent, or the result of the prediction will overweight at some specific factor. The third one is logistic regression cannot distinguish the weight of the data. Therefore, the researchers need to find out the repeated data manually. The last limitation is that the logistic regression can only work on the problem like binary classification, but it cannot predict any continuous outcomes. Okay, I think that's all we have today.
All right, cheers.